In this video, I am going to discuss about region of convergence in Laplace transform. What is ROC? The range of variation of sigma for which Laplace transform converges is called as region of convergence. The values which defines the ROC means the real part of S, that is sigma, defines the ROC. The range of sigma, if we are changing the sigma values, so up to which the Laplace transform converges, that range is called as ROC. For example, if you are having f of s, in that s you are having sigma values. You are varying the sigma values and you are checking convergence of Laplace transform. Up to which this Laplace transform converges, that range can be considered as ROC. Properties of Laplace transform. The first property of Laplace transform is the ROC of x of t includes the straights parallel to imaginary axis in S-plane. So from where you are getting ROC? For that, first you need to take spectrum and then you will get ROC. When you are drawing ROC, first you need to draw S-plane. So it is shown in the figure. It has a real axis and imaginary axis. Then you need to plot poles and zeros. Let us consider one signal f of t. When we take a Laplace transform of it, we are getting f of s. So here f of s will have numerator and denominator. When the numerator is equated to 0, we are getting zeros, and when the denominator is equated to 0, we are getting poles. Always remember that the zeros are represented by a small circle and poles are represented by a small cross. Consider an example, f of s is equal to s plus 1 divided by s minus 1. Now in this case, s is equal to 1 is a pole. So I have marked pole 1 on the axis and drawn a line passing through it. So this is a straight line which is parallel to imaginary axis in S-plane. So if the denominator was s minus 1, s minus 2, we would have got 2 poles. We can get n number of poles based on the f of s equation. So if your signal is a right-sided signal, then the ROC is right half of the S-plane. And if your signal is a left-sided signal, then the ROC is left half of a S-plane. Now the second property of Laplace transform is if x of t is absolutely integrable and finite duration, then the ROC is entire S-plane. In order to understand this, let us consider one example. Now what is the ROC of the rectangular signal ranging from -2 to 2 having an amplitude 2? Now looking at the signal, you know that the signal is absolutely integrable. That is, if we want to find the integral, we will write it as integral -2 to 2 dt. So that will give us some finite value, that is absolutely integrable, and the signal is also having a finite duration, that is the signal is ranging from -2 to 2. So for such signal, without taking spectrum, you can write the ROC is entire S-plane. Consider the third property of Laplace transform. Here x of t is a right-sided sequence. Then ROC will be real of s greater than sigma. Consider the example taken for property 1. Now for this example, if you got this f of s for a right-sided signal, then you need to first draw a straight line through a pole equal to 1 according to the first property, and then you need to draw shaded region towards the right side from this strip line. In this case, ROC will be real of s greater than 1. Fourth property of Laplace transform is x of t is a left-sided sequence, then ROC will be real of s less than sigma. Now again, if we consider the same example, f of s is equal to s plus 1 divided by s minus 1. If this signal is a left-sided signal, then first you need to draw a straight line passing through a pole that is equal to 1, and then you need to draw a shaded region. This shaded region will be now towards left side from this strip line. So ROC will be real of s less than 1. Let us consider the last property of Laplace transform. If the function x of t is a two-sided sequence, then the ROC is a combination of two regions. Let us consider we have a signal which is the combination of two sequences. The first sequence is a left-sided sequence and the second sequence is a right-sided sequence. Now, for the left-sided sequence, we will have a ROC which is drawn towards left side. And for the second sequence, we will have an ROC which is drawn towards right side. Always remember, when you have a combination of left-sided and a right-sided sequence, the common region is considered as a ROC for the given equation. Consider an example to understand the fifth property. Let us consider a signal e raised to minus at u of t. This is a right-sided signal or a left-sided signal? Definitely it is a right-sided signal since we have u of t term. So when we take a Laplace transform of this signal, we are getting 1 divided by s plus a. Now, if you want to find real of s, we need to equate the denominator equal to 0. That is, s plus a should be equated to 0. So we are getting a pole equal to minus a. Now, the question arises, okay, that is whether real of s is greater than minus a or it is less than minus a. Always remember, whenever the given signal is a right-sided signal, we need to write real of s greater than minus a. Consider another signal e raised to bt u of minus t. For this, the Laplace transform is 1 divided by s minus b. So here, the signal is left-sided signal since we have u of minus t. Again, real of s is obtained by equating denominator equal to 0. Now in this case, pole is equal to b. And since we are dealing with a left-sided signal, we write RA of s less than b. Now when we are combining these two signals together, what will be the ROC? Let us do the additions of these two signals, that is e raised to minus at u of t plus e raised to bt u of minus t. Now f of t is a two-sided signal, that is one signal is a right-sided signal and the second signal is a left-sided signal. Then what will be the ROC? So here we have pole minus a for the first signal. So we draw a strip passing through it and draw the shaded region towards right side. For the second signal, we have a pole equal to B. We draw a strip line passing through it and then draw a shaded region towards left side. Now, the combination of these two regions is the common region between these two ROCs, that is varying from minus a to b. So this is all about ROC of Laplace transform. Thank you.